So, why psychology matters, why people matters. And pandemics, it's been said, are like relationship accelerators. So, should we get married? Should we start a family? Should we break up? All these kind of things has sort of helped us realize what matters, and that is us, each other. And the pandemic has also been a catalyst for technological change. We were kind of heading in this direction anyway, but really it has accelerated things. If you think about our uses of Zoom and our reliance on Wi-Fi and how much technology is in our lives every day. But also, not coincidentally, social change, for example, Black Lives Matter, the violence against women and girls, highlighting that, and a renewed look at our history. So we're in this really interesting time of change. And technology, as I'll hopefully argue, reveals a lot about us. One of the things it reveals, I think, is this idea of neurodiversity, that differences in the gene pool are, or should be seen as just differences rather than not necessarily abnormalities and deficits. So I'll come into a bit more detail about that. And about changing the environment. And nothing is better at changing the environment than technology, rather than changing the person. So I'll go into a bit more detail about how psychology and psychiatry is focused a lot on altering things about the individual rather than trying to change the environment around them. And I'm a passionate psychologist, and I want to explain why I'm interested in robotics and AI, and also a little bit about the power of child development, because I'm a developmentalist. And I've seen this both as a parent and as a scientist. And also as an interdisciplinary researcher, I want to talk about the work that I've done with my interdisciplinary colleagues from computer science and engineering, and how they reflected back on my own discipline and helped me view things differently, because otherwise you can be a bit of an echo chamber hearing things back. So these are some of the themes. I don't know if you can see this slide very well, but we're in this sort of mental health crisis, as it were, in children and in adults. And if you look here at this line, this is the number of referrals of young people to mental health services. You'll see this sort of steady incline here, and then the pandemic hit, and now we're at this level here. So there's a 77% rise in the number of children seeking acute services. And some of these numbers are quite horrific. For example, in England, you've got 400,000 children under 18 referred to the NHS, and in Scotland, 4,500. And children and young people started treatment in child and adolescent mental health services between October and December last year, a huge increase of 20%. And so what this shows us is that the pandemic has hit the mental health of children and young people especially badly, and we're going to be seeing some of this through our own, through the next few months and years. And what Sarah Jane Blakemore has argued about is, sorry? Oh, okay. Is this a bit better? Do I need to be a bit closer? Okay. No, thank you for saying that. Tell me if you can't hear me again. I hope you got some of that anyway, at least. Is that better? Thank you for saying that. Yeah. So so Sarah Jane Blakemore has mentioned and done a lot of research into adolescence, this sort of time period in our life. And it's a time in which she argues we invent ourselves, we sort of show who we are and decide what kind of person we want to be. And in lockdown, probably a lot of you have had to work very hard on what we call social capital, maintaining our social relations, even though we don't see people. So the structure of my talk is going to be about sort of how I got started a little bit, and about my collaborations, and this idea of the so-called lone genius. This view of researchers who work on their own really no longer applies, and this is something that Dorothy Bishop has said. And so I've worked with a lot of great people who've helped develop me and whose work I've contributed towards. A little bit about the timeline, both in terms of my experimental work, but also my theoretical work, and interestingly, some personal things around the development of my own children. And then I'm going to be talking about two sets of technology, so virtual characters and virtual environments. And I'm going to be talking about a couple of psychological theories, one called joint attention and one called executive functions. And then I'm going to be talking about robots in relationship to what we call expressive behaviors and also on trust. So I'm going to sort of cover a fair bit and probably go not into too much detail in everything, but a little bit of a broad brush. So how I got started. Well, everybody needs someone to believe in them. and for me that person was Peter Mitchell. And unfortunately Peter can't be here today. He was my PhD supervisor, and that's his photo, and he supervised my master's degree as well. And he wrote a pretty seminal book in our field called Introduction to Theory of Mind, Children, Autism and Apes. And as an autism researcher, we look back at the history of autism, and it really does mirror the history of psychology. So if you went to a psychology department in the 1960s and 70s, people will be talking about psychoanalytic theory and then behaviorism. And at the time, in the 1960s, there was a book written by Bruno Bettelheim called The Empty Fortress, and he put forward this idea of this refrigerated parenting, this refrigerated mother specifically idea, that somehow the mother was causal in the causing of autism. Completely discredited idea, but that was the zeitgeist at the time. And then we move on to sort of behaviorism, which is still around today, and this is sort of operant conditioning and classical conditioning. It doesn't really explain autism, but what it does is to try and treat it in a certain way. And so if you went to psychology departments at that time, this would be the dominant sort of ideas. But in the 70s and 80s, we moved into this so-called cognitive revolution, where people started to think about the mind. And later on, with cognitive neuropsychology, people started to think about how the brain and the mind were connected as well. And at this moment in time, Peter, my supervisor, and other people were looking at something called theory of mind, which I'll come to in a bit more detail. And this is about how we understand the mental lives of each other. And at that time, in his book, he wrote about children, autism and apes. And now, I think if he were to write it again, he would change it to, instead of keep children, but instead of autism, he'd probably say autism spectrum disorders. Instead of apes, he'd say non-human primates, or use something like comparative psychology. And I think he'd probably also introduce the idea of robots and autonomous systems. So this is a view of the human brain. And the particular part of the brain that I'm interested in, although I'm not a neuropsychologist, I'm interested in the functions around that, is this medial prefrontal cortex, which is the real sort of social part of the brain. This is all the social brain, but this is the specific area that I'm interested in. And the human brain is amazing because really for a mammal of our size, and the fact that we're in on two legs, our brains are 6 times bigger than they should be, which means that we actually are birthed very, very young in terms of our development, because otherwise our heads would be too big and we'd die in the birth canal. So we're actually born very, very underdeveloped in terms of our brains. And so that tells us an awful lot about the relative dependency we have on our parents as we grow up and on the wider community. And it's quite unique. And in fact, interesting enough, adolescence is a time in our lives that no other species has. So my experimental timeline really goes from when I started my master's degree in 1998, when I started to look at computer role play, and then I moved on to looking at text chat, and then in virtual environments and touch screens and graphical characters, and finally onto robots and autonomous systems. So looking at things like emotions and trust, and now I'm looking at conversational agents as well. So you can see this sort of time point in our technological histories has sort of marked my work as well, starting all the way here, all the way to touch screens and iPads, and now we've got these sort of devices coming into our lives every day. At the same time as experimenting, I have a theoretical timeline, so I've published work trying to characterize and understand developmental conditions and how they interact with technology. So we sort of move away from the idea that there's a single deficit that can account for autism to multiple accounts in 2007 when I wrote this paper. And then later on in 2013, I talked about how these theories could be applied to virtual environments, and I made the case to change the environment and not the person, which radically goes against a lot of sort of psychiatry and psychological doctrine, when a lot of it's around there's something wrong with this individual, they need to be fixed. And then in a chapter in 2019, I talked about biases in terms of AI, and biases also are part of the diagnostic systems as well. And I talk about inclusivity and this idea of neurodiversity, so the idea that within the natural variation in the gene pool is there for a reason, because nature needs error, and error is not something to be got rid of. because that's part of how we survive as a species. And then finally, I have a paper that I have to make some small changes to, which is just almost ready to go, in which I have this research methods guide, in which I'm going to be talking about what we call heterogeneity. So that's the variation within individuals and how it's important to look at what goes on, what I call the process as well as the outcome. So I'll go into a bit more detail about that. So in terms of understanding other people's minds, okay, this is the power of intentionality. And I'm not defending Boris Johnson in any way whatsoever. I'm just saying that this is the ideal defense. And what is intentionality? So when he says, when I went into that garden just after 6 on the 20th of May to thank groups of staff before going back into my office 25 minutes later to continue working, I believed implicitly that this was a work event. So you can't see into Boris Johnson's mind. There's no way you can. So it is the absolute perfect defense in terms of how can you know what if you genuinely believe this or not. You might say this is implausible, but the fact of the matter is he talked about belief. And belief is important in a number of different ways. This is a paper by Thomas Zimke, published in Science Robotics. And this is about interpretation of robot behavior. As soon as I saw this paper, I highlighted all these bits which were explicitly psychological. So imagine you have an autonomous vehicle and a pedestrian encounters this driverless car at a crossroads, and you might be asking yourself, has that car seen me? Well, that's about perception. But does it understand that I want to cross the road? Well, that's about understanding mental states. And does it intend for me to stop? So implicit, even in something like this, is an understanding of what's going on in other people's minds. So, if I show this photograph, immediately, as most, if you're neurotypical, you'll be decoding this. And the decoding usually is that the guy is with his girlfriend or wife, he's checking out this other person, this other girl, quite obviously, and the girlfriend or wife is not very happy about this, okay? That's the common interpretation. And Temple Grandin, who has autism and is an academic, calls neurotypical people emotibots, because we only have to see this to start reading what's going on very, very quickly, and we do this very, very rapidly. I wanted to look at more detail in this, and this is my first publication. And this is what happens when you are the lowly master's student in a lab. You get the low-tech stuff to take around. So I had an Apple Classic, which still has a good place in my heart. It belonged in a museum even then, but I was loaned it. And I used it to interact with a young man here with Asperger's syndrome, with autism, in what was computer-mediated role-play. So there was a piece of software created by people at the Open University, which I borrowed, they kindly loaned to me. And then what I did was interact with the person next to me, but rather than interacting face-to-face, we interacted with characters in this environment. Now, traditionally, if you're trying to understand what's going on in the mind of people with autism, one of the things you might want to do is look at how they understand non-literal language. So if I used non-literal language in a certain way, you might say, well, does this person really mean this? Is this person being sarcastic? Are they using a figure of speech? So in order to understand what's going on, you have to decode what's going on in the person's mind rather than literally understanding what's said. Typically, tests like this were given in story vignettes like this one. So Daniel and Ian see Mrs. Thompson coming out of the hairdresser's because she looks a bit funny. So she looks a bit funny because the hairdresser has cut her hair much too short. And Daniel says she must have been in a fight with a lawnmower. And what people would do is ask children or adults with and without autism, is it true what Daniel says? And the correct answer would be it's not true. And then why do they say this? They might say, well, it's a figure of speech. They haven't really had a fight with a lawnmower. And I argued that this looks at something at what we call working understand, sort of reflective understanding. So this is how somebody might reflect on something. But what do they do if you put them in the position of these characters? Do they show a different kind of behavior? And notice here that this is very low-tech stuff. And this theme keeps coming up. It's not the technology that's important, it's the psychology of this. So here, in this piece of software, I role-played one of the characters and set up the exact same scenario Daniel and Ian see Mrs. Thompson coming out of the hairdresser one day. She looks a bit funny because the hairdresser's cut her hair too short. So my character types, she must be in a fight with a lawnmower. And you expect the person with autism, if they didn't understand, would say, oh, I hope they're not bleeding or something like that. Instead, they write a lawnmower more like some shears. So something that seems completely semantically appropriate to show understanding. Along with this, I decided to look at what we called appropriacy, what I called appropriacy. And this allowed me to look at the kind of behaviors that you couldn't do in real life, but you could do if you role-played and you kept it ethically tight and environmentally controlled. So Katie's in a pub, she sees a man who she thinks looks nice, she decides to go over and talk to him. And this is my opening gambit. Tony, I know we hardly know each other, but I wonder if you could lend me some money. About £100 ought to be enough. So what does the person with autism respond? Katie, I really do not think it's a good idea to lend you some money for the reasons that you state. So kind of dry, but potentially appropriate. Or are you drunk, or do you think you can walk up to a man and ask him for money? So this is the kind of work that I looked at, both in terms of non-literal language, but also in trying to understand social vulnerability. Now my PhD student, Tony, is here today, and she took this work forward, and she used story vignettes. And she was looking at vulnerability in children using both this story vignette and this role-play scenario. And she created some stories that were looking at what we call disinhibited behavior. You get this in certain children with certain vulnerabilities called disinhibited social engagement disorder. And this vignette here talks about Jane getting on the bus from school. When she gets on the bus, instead of sitting with her friends, she sits beside a lady whom she doesn't know. Jane asks the lady which is the best stop to get off at the shopping centre. The lady tells her to get off at 3 stops. When the bus stops, Jane decides to get off with the lady. One of Jane's friends shouts on Jane to come back. So she's done something inappropriate. And what's really interesting is that when you have a number of scenarios, you can see this developmental difference between children aged 6 and 8 and 10. So you see a lowering of their kind of disinhibited or inappropriate behaviors as they go down. But interestingly enough, when you do it in role play, you see more of these behaviors. So the idea that in role play, more of this kind of inappropriate behavior leaks out. So we've carried on this work. This is funded by the EPSRC. Unfortunately, we had to stop this during the pandemic, but we're carrying it on in terms of developing some software to do this that clinicians can use or people in schools can use in order to use some of these role plays as maybe some sort of learning or some sort of stranger danger testing. This is called test play. And so we're starting this work up again. So this is my theoretical paper. And this is around autism and how I explained there was no single neurocognitive explanation. And what I focused on is theory of mind, this understanding of other people's mental states that you can measure in different ways, including looking at non-literal language. The other area that I focused on is something called executive functions, and I'll come on to that. And that includes things like multitasking and planning. I haven't done so much work on this aspect, which is the perceptual aspect. And at that moment in time, I thought, this is great. I've written a seminal paper, and I've said, no one thing can explain autism. There's multiple deficits, and this is what I think of it now. And that's because it's what I call a static theory. We're back again to not looking at interactions with people. We're looking at, again, there's a problem with an individual, we need to fix them. And it's my colleagues in computer science who opened my eyes to understanding interaction better and how our models in psychology and psychiatry need to be better. And I've tried to replace it. My children told me to put Mr. Messy here. It's messy but more closer to the truth, this idea that I've written about in this paper. And I would say that the clinicians have it easier because you can see that every child is different from each other. But as experimenters, it's harder because how do you characterize these differences between groups? Because there's no theory-neutral position. Because as soon as you say, oh, it's something to do with IQ, you've already decided pretty much that there's a position there. One thing we do know about autism is that it's a developmental condition. And it moves from this idea of the inactive mind, where people with autism seem to have difficulties in terms of knowing the importance of eyes, to what we call joint attention, which is a pointing and being able to show things in the environment. This is called proto-declarative pointing. So chimpanzees can do what's called proto-imperative pointing. They can point to want, but humans are really pretty unique in pointing to show. And by the end of the first year of life, children are doing this. This is my daughter, when she was a bit younger, pointing and showing. So pointing is a really powerful human thing. And it cascades these aspects of early development to understanding about joint attention, to finally this idea of theory of mind. So this is something that most developmentalists and autism researchers kind of agree upon. And I would argue that joint attention and technology has never been a solo activity. And people say, well, how antisocial are people these days? Well, if you look at this crowded train here, there's a whole group of people who seem to be not interested in each other, but reading papers. Whereas you have a family here, gathered together, interacting with each other in terms of the social element with what we call a wireless. And you have my children here, even though they've got a phone here, they're kind of interacting, and my daughter's there taking a photo of my son. So technology in itself is not bad. It depends how it's used. So one of the things that people are pretty sure about in terms of autism is the problem not of responding to joint attention. So if I point, people with autism seem to be able to follow that gaze, but it's initiating, which means, having the social motivation to point something out to somebody else. That seems to be the issue that most people are agreed upon. And my student Gillian, who I believe is here today as well, she did some fantastic work looking at this in a bit more detail with a virtual character. And what she did was she set up an eye tracking system, you can see it here, and this is a virtual character, Danny. And you can do both. What she did was you could do both what's called initiating and responding to joint attention. So usually the character would look in this either left or right side of space here, and the person would respond by looking in that direction. The eye tracker would see where you're looking at, in the left or right. But very, very neatly, what Gillian did was also set up a situation where the participant could decide which of the boxes to look at, and then the virtual character would look in either side. Does that make sense? So you could kind of decide, in one condition, the participant gets to decide where to look, and the other condition, the virtual character decides where to look, left or right. And this was sort of brand new work at the time. And sort of Gillian sort of set this up, this numerous sort of experiments. So you've got the presentation of what happens, and effectively you've got these two conditions, one in which the participant decides where the character looks, and in the other condition, the character decides and the participant looks. And there are various objects that are shown either left or right side of the character, and you have to remember, your job is to remember the item for a memory recall task. I won't go into too much detail about the study, just to say that Gillian found that both the ASD and the TD groups, the memory for the target didn't really differ between them. However, when you look at the viewing times, they were different, and they showed a similar pattern regardless of whether they were responding to joint attention or initiating attention. And that's that typically developing groups spending more time viewing the target, and the ASD group spent more time looking at Danny and the non-target. So the argument here is that it's not a deficit, there's a difference. So something different is going on rather than something has gone wrong in the system. Now, my colleagues, Kasia Parajska-Pomska and I, in the ECHOS project, looked at joint attention in a little bit more detail in terms of a virtual character, so rather than just the head. And this is a paper that we published, and the best way of me showing this is via video, which I've shown before, but it's no less powerful. And this is a young man with autism who is about 7 years old, and is interacting with a virtual character called Andy. And he does something quite remarkable, which I will, hopefully this will work. So he's grabbing one of the balls and trying to give it to the virtual character. Okay, according to theory, that shouldn't happen. This is a virtual character, doesn't even have a mind, and yet the child with autism called him by the name and pointed to something and said the ball changed colour. Now this didn't happen for all the children, but in this certain context it did. So once again, it depends upon the context and how you set things up. Fast forward to, I guess this is not a photo of my children, but if you were born in 2010, like my daughter, I've got this lovely video, various videos about children showing iPads. So that came around about that time. And then the child is shown a magazine and tries to scroll the magazine. And so rather than spending time showing you that video, I wanted to show something, I don't know if you've seen this before, about why it's so difficult for computer scientists and roboticians to try and mimic child development. So if you're born in 2020, everything looks like a hand sanitizer. So that's the power of child development right there. I could spend a lot of time showing you various papers, but that in a nutshell shows how tricky it is to get robots to do things that human infants do. One of the things that I wanted to show you about that is that's what's called a prepotent response. You can't stop yourself from doing it. And that comes under the other thing that I mentioned around, as well as theory of mind, about something called executive functioning. And executive functions are basically also located in the frontal lobe part of the brain. And they're things to do with planning. So think about executives. So my university colleagues here in the executive plan what happens at the university. And if they were all to be wiped out, the university would function okay, but eventually have no strategic decision. So the executives are important, and that part of your brain is important. And anybody seen this? Is the wonderful Stephen Graham in Boiling Point. And two tasks of executive function are really interesting, and they are multitasking. And in multitasking, we've got two tasks which are really interesting. One is cooking, and the other one is shopping. And the reason why they're used is because they both involve this endpoint. So think about cooking a meal. You have this endpoint in which you have to produce this meal, and you have to do these subordinate tasks in order to get there. And shopping as well. You have a shopping list, and you have to get all the items in the basket and get them in there in an organized time. And people who have either had a particular kind of frontal lobe injury, or as you're developing, this ability starts to develop. And this comes under broadly executive functioning. And what I did was, I wanted to look at this in more detail in adolescents with autism. So here, we created what's called the virtual errands task. Well, we borrowed it actually, but used it for the first time with people with autism. And this is a paper that was published in 2011. So you've got to imagine that you're a student in a school, and your teacher is very busy, and they ask you to run some errands. This is very much like your shopping. We argued what's called ecologically valid, because it's like a real life task, but you're the first person in like a computer game, navigating around a virtual environment. And here we recruited adolescents with autism and typically developing individuals. And we had various situations where we had a training phase, and then we did a screening phase, and then we did the virtual environment itself. And this is the instructions they got. So you've got to imagine you're a student in a school, and your teacher asks you to run some errands, and the errands are listed below. And you have a limited period of time, and you can switch between these errands, and you've got certain things that you can't do. So you've got to collect this telephone card from a cupboard, then deliver them here, these various steps. And then once you finish, you go back. So you've got to imagine yourself scrolling through this virtual environment. pretty much like you're doing shopping or something like that, and you're giving this plan of the school. And what we found was, interestingly enough, we found that people with autism were not as good as multitasking as people without autism. So this is the main score here. And we found that they broke some of the journeys, some of the rules, and they broke some other rules here, and they spent more time doing something or other. So in a sense, it tells us something that we kind of knew anyway. But we broke the analysis down, and we found out something interesting, is that if you give people with autism this particular list of rules, they tend to follow it more in the order that it's given. So imagine you're a student taking an exam. Maybe you want to do question 6 first. Maybe you want to do question 1 last. But if you give the order in this format to people with autism, they're more likely to follow the order. So maybe in exams, maybe we should just put our questions all over the place, rather than implicitly applying they should be done in a certain format. There was also issues with what's called prospective memory. So that's the remembering the intention to do something. So you're driving along and suddenly you think, I need to buy flowers, it's my wife's birthday. Where does that come from? That's the kind of thing that you kind of remember, and those are the things that our autism and adolescents had more difficulty with. Okay. Now I'm going to do a bit of audience participation as we move away from sort of virtual environments and virtual characters to robots. So I'm going to ask you to choose. I mean, how I'm going to do this. Maybe a show of hands is probably best in COVID times. So what is a robot? Is it your plastic pal who's fun to be with? Anybody want to put a hand up for that? No? No takers? A humanoid machine with artificial intelligence. We've got a few takers, okay. A device that can learn and obey human commands. Okay. Got a few, there's none of the above. Okay. Okay. I would say there's no universally agreed definition of what the robot is, but it has elements of some of those things apart from, I suppose it could be a plastic pal that's fun to play with too, which is from the Hitchhiker's Guide to the Galaxy.
If I'm not wrong, all the 3 could be right, ABC.
Yeah.
If I'm not wrong, all the ABC could be right.
Yes. Yeah. I think a better question is, what's a socially assistive robot? And if any of my students are here, they'll be used to me putting up this jargon buster. And here we have a socially assisted robot helping out with some older people or somebody interacting with them. This is a Pepper robot. We have quite a few of these in the university. And a social robot is an autonomous or semi-autonomous robot that interacts and communicates with humans by following the behavioral norms expected of people with whom the robot is intended to interact. So you've got a better definition. And so it's probably useful to define our notions of what a robot is in terms of what they're intended to. Now we go back to some theory. Okay, so anybody watch the Oscars? Okay. I'm not going to go into details about what happened, but you can see some pretty impressive interactions going on here. Taika Waititi here. I like Jason Bateman. He's sort of looking pretty chilled about what happened. And Ron Howard here. And what's going on here is there are not one mind involved here. There are lots of minds going on in terms of this interaction. So if I was to draw a bubble here, there'd be lots of things going on. This is a bit more of a darker example recently. So you can see Vladimir Putin at one end of a table here and his generals at the other end. And you can see some sort of mind here between these two, with basically him saying, this is how it's going to be, and them saying yes. But you can see the interaction here. And as we move away from thinking about minds individually, we start to think about minds interacting. And we realize that this is a very important theory. It's called the double empathy problem. And this was put forward by Milton, who has autism himself. And he argues that this, I won't read this out, but basically what he argues is that there's a problem of connection of minds between neurotypical people and people with autism. And rather than it being a problem with them, it's a problem of this interaction. And Catherine Crompton and colleagues have done research to try and operationalize this, to try and see what's going on here in terms of peer-to-peer transfer. And what Milton argues and Crompton found is that people with autism are actually better at communicating with other people with autism, and neurotypical individuals are good at communicating with other neurotypical individuals. The problem comes with interaction, and that's where the issue is, the interaction of the minds, rather than one mind being wrong and one mind being right. Now, Robots, potentially a solution to this? Well, this is one area of research that we're looking at. And this is the SOCO Row project. And here we use this robot with an MS head. And the reason why we used it is because it's got 15 degrees of freedom. It's not as expressive as the human face, which has about 42 action units. And the idea here is that you have a robot that has much greater expression, and so it signals in a much bigger way when it's annoyed with you. And people with autism say, sometimes in the workplace or in social environments, I don't know what's going on because the social cues, the subtleties of the social cues, I don't get it. I don't know if somebody's angry with me or not. And I've got this idea of cognitive load. And the reason why I mentioned friends and other things and why they're so important to us, we think about cognitive load in a certain way. This person is really hard work. What does that mean? The friends around us, the people who we most affiliate with, are really easy work. We love being with them because we don't have to work too hard. And an extension of this is in the work environment. And so what happens if you have a robot as your boss for which you don't have to work too hard if you have autism in terms of understanding whether they're annoyed with you or not? And that was the basic premise. So pre-pandemic, this is my son here, and this is the full robot. And this is just one of the studies that I'm going to explain today, in which we used the robot head at the Glasgow Science Centre and asked people to put into a tray whether this object was liked or disliked. And it didn't really matter whether it was liked or disliked. What mattered to us was the way that the robot expressed itself. And we wanted to see whether there was something was approving or disapproving, disapproval. And we had these various candidate expressions here. And this is why it's important to do science, because you can kind of think, we believe these things to be approval or not approval. But when you actually do the science, people tell you things differently. So the way I'll break this down is, for example, this is if you had this expression in the robot, people said, yeah, they definitely like the object. And this one here, can you see the nod down? Definitely didn't like it. But some of them are a bit tougher. There was one which was a wink. Can you see that? We said, winking, that's bound to be approval. People are going to like that. But the robot did it quite slowly, so it was like this. So if somebody does that to you, maybe think, maybe that looks a bit dodgy or suspicious. So that's why it's important that we actually ran the study rather than assuming that the literature told us the truth. And here's it in a bit more detail. So these are the ones that are the really good candidates. The head up, the smiling, yeah, definitely approval, definitely disapproval. And here are the other ones where a bit more disapproval. And this was the wink one, which we thought was approval, but wasn't. Finally, to wrap up with, there's a project I'm involved with, and Helen Hastie, our PI on the project, is here in the audience. And this is about trust and autonomous systems. So this study that I'm going to be talking about is absolutely hot off the press. So how do we look at trust? Well, trust can be defined in a number of different ways. As psychologists, we're interested in the interaction between individual differences and situational factors. And I have a colleague of mine, Yavor here, who's an individual differences specialist with whom we collaborate with. And is it an attitude? And does it sort of help us achieve individual goals in a situation characterized by uncertainty or vulnerability? Or is it a trait? Or some combination? And as psychologists, we're interested in finding out what the relative contribution is of the context. So it could be the robot or it could be the particular thing, and how much is to do with individual differences. For example, it could be your IQ, or if there's a propensity to trust. Maybe some people are more over-trusting than others. Does it really matter what kind of robot we have? And that's the kind of thing we're trying to find out. Rather than holding up our hands and saying this problem is unsolvable, we're trying to say what's the relative contribution to these things. And here's something for film fans. This is the ultimate first date. Come with me if you want to live. So this is Kyle Reese and Sarah Connor from Terminator. And so one of the studies that we did in the pandemic, so we didn't do this with people in the laboratory, although we'd love to, is this study looking at mazes. So this is a famous maze, probably one of the most famous in the country, is Hampton Court. I think it's Henry VIII's home. And imagine you're in a particular maze and you have a robot, and the robot tells you, I'm going to lead you out of this maze. What would you base your trust on its ability to get you out of that maze? Would you base it on behaviors, or would you base it on intentionality, on its ability to understand other people's minds? And I'd especially like to thank Peter McKenna and Marta Romeo for help with this on our project. And this has just been submitted last week to a conference called Romance, so it's hot off the press. So those are the things to think about. Would you trust it, and why would you trust it? So we have 3 conditions. So a third of the participants were primed with a video of a robot that simply stated which maze to follow. So it just gave you instructions. The other third were primed with a video of a robot that had a sensor and that gave advice and directions based upon its hardware. And another group were given a so-called theory of mind robot. So it didn't actually have a theory of mind, but it mimicked having an understanding of mental states. And they expressed the ability to take participants' thoughts into judgment. Critically, the robot behaved in all 3 conditions exactly the same. The only difference is in how they were primed. Okay? So we'll come back to this. And this is an example of what happened. So you've got the Pepper robot here, and they see the video of it, and then in the mazes, they're given 10 of these, and you've got these exit paths here, P1 and P2, and the participant has to decide whether to trust the robot or not. And the participants completed the task with the help of Pepper, who suggests an exit. So the Pepper robot here, just the face, suggests either going this way or that way. And the question is, do you trust it? And here we have something that I've been looking forward to for a long time, is looking at the development of something, rather than looking at a one-time moment. And this shows you the various trials. And this measure here is, we've got quite a few measures, and this is the decision time. So how long does it take you to decide whether you want to trust the robot or not? And on trials 1 to 4, you have this building of trust. So the robot should be trusted because it gets it right, it gets you out of the maze. Then on trial number 5, it makes a mistake. It takes you to the wrong place, so the trust is now broken. And then you find a dramatic sort of decrease in the time it takes for people to make decisions. And then we go back to trust being rebuilt again. And then on the 10th trial, this is an assessment of trust trial. It's the same format as the trial 5, where it makes a mistake and this breaking of trust. However, this time the advice is correct. And here we aim to assess whether the trust was rebuilt during the trust rebuilding trials or not. So what we find is that when you mimic this idea that the robot can understand other people's mental states, people are generally more skeptical in deciding whether or not to trust this robot. And this is true for these highly ambiguous contexts, so for example, breaking of the trust. So it could be that people are ascribing human fallibility more to the theory of mind robot than the other robots, because you've been primed that it has a mind. So why is it making mistakes? And so going back to Temple Grandin, and maybe she was right after all, that neurotypical humans really do seem to be emotibots, that we really are sort of looking for information and searching for understanding when there really isn't anything. So I'm going to finish off now with some slides to thank the various people in my lives. And these are my former PhD students. So Heidi Stieglitz-Hamst. Heidi couldn't be here today. She's in Texas. That's where she's from and lives. And then there's Gillian Little and Peter McKenna. Gillian's here. Unfortunately, Peter couldn't make it. And this is when we went on a jolly to Cambridge. So I take my PhD students to wild places. And these apples here are generational from Newton's apple. You know, the one that landed on his head? I believe that's the case. And then we have Stuart. Stuart's here. Did wonderful work with me on executive functioning, and Tony as well. So we've got Heidi, and then Julian, Peter, Stuart, and Tony. And then my current PhD students. So we have Lorna, Bitter, Isabel, and Nicholas here. And then I'd like to thank all the organisations I've worked with, because I mentioned that no person is an island, but certainly no researcher in this modern world can do this without help of people. And I have a long list of collaborators, but these are the people I've been working with the most. From Came School, special needs school in Edinburgh, specialising in children with autism, autism initiatives, all in Edinburgh, and these are the various teams. And these are all the wonderful colleagues I've worked with and collaborated with. And I've been very lucky, very blessed to work with people who are very experienced, and also people who are very bright young talents too. Finally, some blatant bit of advertising since I'm here. So myself, Stuart Miller, and Professor Lynn Bailey will be speaking at the Edinburgh Science Festival. So if you like what I've heard tonight, I'm going to be talking in a bit more fun, I suppose, or a bit more looser ways about robots as our servants, assistants, or companions. So this is an excellent film, Robot and Frank. Everybody knows Metropolis, I guess. And then if you're a Star Wars fan, you'll get this joke. What's the probability of these talks being any good? Well, it's high, very high. Finally, World Autism Awareness Day, this Saturday. There are lots of events, so check that out. And then the last slide. Thank you very much for listening and coming.